All right. So I had some questions on episode 3, so I wanted to go over some of the topics here. So this first task right here, looking at this pattern, really is a lot of what we did in Math 11. So I thought that starting out with something like that for familiarity's sake would be good for the first week. What I give you though is I give you the actual function. So all of the stuff following up to this should be pretty attainable. But we're gonna kind of dive into just this pattern and what happens as we continue the pattern. So I'm gonna come down and draw a little bit on my own. So we've got steps and we've got tiles. So this first step of the pattern has 2 tiles. The second step, I'm going to draw it out kind of as I see it. So I see it as this middle. And then I've got these 4 prongs, and then I've got a repeat of our 2 added corners here. And so what I have here is I've got step 2, which has 1, 2, 3, 4, 5, 6, 7 tiles. And then if I look at this next pattern, you'll notice I've got my 4 in the middle, and then I've got the wings, and then I've got the 2 on the outside, right? So if I do that, 2 by 2, 1, 2, 3, 4. So I've got 4 plus 2, 4, 6, 8, so 12, 13, 14 tiles in that one. So if I continue this pattern, really I could keep going. So I can go 3 by 3 in the middle, and then I've got the wings. And then I've got my 2 pieces in the corner. So I've got 9 plus 12 plus 2, which gives me 23. Let's do one more. Let me see if I can select these and move them a little bit down. And then I'm going to draw step 5. So if I draw step 5, I'm going to have that 4 by 4 in the middle. I'm going to have the wings, each with 4. And then I've got the ends. So for step 5, I've got 16 in the middle, 4 by 4. So I've got my middle, which is 16, and then I've got 16 on the edge, so that puts me at 32, and then the 2 gives me 34. And then we'll break down, this is just the way that I perceive this pattern. There's other ways that you could. I'm going to highlight the same things too. So this middle box is that, and then this will be important in the end, and then we'll make these guys blue. Okay. So how does this help us with this pattern? Well, we can make a table of this. We've kind of started that, but now we can start to diagnose a pattern. So let's do that. I'm going to go up and down for this one. So my step numbers and my tiles. So I know that 1, 2, well, let's go a little bit smaller. So that 1, 2, 3, 4, 5. And I've got 2 tiles, 7 tiles, 9 tiles. Oh, excuse me. I'm writing the wrongs. 2, 7, 14, 23, 34. So we don't see a pattern right away, but the question here says, is there a step that would have 167 squares in it, so tiles? So I want to know if there's ever a step that has 167. So if I wanted to do that, I could just I could look at my pattern here. I could continue to draw, but that would be kind of cumbersome. So let's take a quick look at the pattern here. If you remember back to Math 11, we did these things called finite differences, where I look at how much am I adding to get from here to here. I'm adding 5, right? 2 plus 5 is 7. 7 plus 7 is 14. 7 plus 9 is 23. 9 plus 11. Oh, look, we have a pattern here. And it should have two finite differences because I gave you the quadratic. So if we check that, you'll notice 5 to 7 is 2. 7 to 9 is 2. 9 to 11 is 2. And so from this point, I don't need to draw any more pictures. I have my pattern. So I know that for 6, whoops, that shouldn't be red, it should be black. I'm going to add 13. So I'm going to get 47. And for 7, I'm going to add 15. So 50, 62. For 8, I'm going to add 17, which gives me 79. And I'm just going to keep going with this color. Plus 19 gives me 80, 98. Plus 20 gives me 118. So this is one way that you could explore this pattern, and this is how we did a little bit with the last plus 22. Ooh. Oh, goodness sakes. I'm supposed to add 21 here. So this should be 119. Add 23. 142. And 25, 167. I think that's what we were shooting for, right? If we go back. So we just found out that if we draw step 12, that it'll have 167 squares in it. And so if not, which step is closest to 129? So if we look at that, 129, it looks like 129 is closest to step 10. So a little bit of that. How can you tell the patterns? Sketch a quick graph. So before we sketch a graph, I just want to talk about how we get these patterns here and where do they come from the visuals. So I'm going to erase a little bit of this, some of the differences, and we're going to talk about this. So, and I'm actually going to start at step 2. You'll notice that step 2 begins with 1 squared in the middle, and then I've got 4 by 1 blocks outside, and then I've got these universal 2. And that pattern is how I observed this and built this. You might have seen something different, and that's perfectly fine, but you'll notice it happens the entire time. So I'm going to write it out that way. So I've got my green, whoops. So this is equal to 1 squared, and then my red, so plus 4 times 1, and then my blue, plus 2. And then my next one is 2 squared, plus 4 times 2, plus 2. And this is 3 squared plus 4 times 3. Whoops, I guess I should have done that in the same color. Plus 2. And we see this pattern continue. If you look at it right here, these are each one less than the step number. So we can actually use the step number to come up with the equation. So T is going to equal, the number of tiles is going to equal the step number minus 1 squared plus, and then you'll notice that that number shows up here again, but it's being multiplied by 4. So 4 times s minus 1 plus 2. So now I have a relationship between the number of tiles and the step number. So I can evaluate this and simplify it. I could also just use this, but yeah, let's just evaluate this. So this right here will FOIL. So s squared minus 2s plus 1. Then this we're going to distribute 4. So 4 times s, 4 times minus 1, and then add 2 in the end. Now we're going to combine like terms. Let me box this off a little bit. So t is equal to s squared. It's my only s squared term. And then I've got plus 4s minus 2s. So that's going to be plus 2s. And then I've got minus 4 plus 2 plus 1, which ends up being minus 1. So let's go take a look at the graph. So it did say in our task to graph this function here, x plus 1 squared minus 2. So let's do that. X plus 1 squared minus 2. And now what I should have started with really is a table of values. So I started off with my, let's say x is my steps. Call this S1, and this I'll call T1, but 1, 2, 3, 4, 5, 6, 7, 8. We went up like way up there. So, and then if I plot those, I've got 2, 7. Let's just squeak this between. And we will go really low here. We'll go up to like 100. All right, a little bit better to view. So 2, 7, 14, 23, 34. What else? Where's the rest of our table? We could really plot that and then it'll continue to show. 34, 47. Whoops, I typed 34 twice. 62. And this shows us that we were making our calculations correctly because those points are landing right on the graph. Keep zooming out. 119, 142, 167. Sweet. So this looks different than what we have written though, right? Like I wrote out t equals s squared plus 2s minus 1. So if I were to write that out again, it's s squared plus 2s minus 1. So it actually doesn't like s, so let's give it an x instead. And let's change the color. Let's go green. All right, if you take a look, like if I turn the red off, hey, they happen to be in the same spot. These are written differently, but they represent the same graph. Same graph, written differently. This is in standard form. Let's add a note in here. This one here is in standard, sometimes called general form. And then one above is in vertex form. And we took a little bit of a look at that in Math 11, but you're going to do that a little bit in week 2, which is this week. So, yeah. I think that covers that first part of episode 3. And if you have any questions, email me specifically. But if you look on the second task over here, really the second task is very, very similar to the first task. And so let me know if you have questions, but hope this helps.